In this video, I will show you how to do some proofs, specifically proving that triangles are congruent or that their corresponding parts are congruent. A good place to start is with the given, both writing it down on the chart and marking it on the diagram. So angle B is congruent to angle D. That's already been written for us, but we need to mark it. So here's angle B, and that is congruent to angle D. Now, C is the midpoint of BD. That's already written down, but how do we mark this in the picture? The way you mark this in the picture also leads to the next statement that you're going to write down. Midpoint of segment BD, you say. Well, here is segment BD right there. If C is the midpoint, that means that this side is going to be congruent to this side. All right, because C has to be right in the middle. All right, now, what did I just mark? Because that's going to be a statement in my proof next. Notice how I just marked segment BC congruent to segment CD. All right, so segment BC is congruent to segment CD. Now the reason is definition of midpoint. Sometimes students aren't sure whether to put definition of midpoint or definition of bisector. For a hint, always look at the previous statement. If the previous statement says midpoint, it's probably going to be definition of midpoint. If the previous statement says bisect, it's probably going to be definition of bisector. All right, now, what else can we mark congruent in the picture just because of the way the picture looks? Well, we can mark the vertical angles as congruent. So this angle and this angle, these are vertical angles, they're going to be congruent. So that was angle BCA congruent to angle DCE. Now, I mentioned these are vertical angles, so that's the reason we just write vertical angles are congruent. Vertical angles are congruent. Or you could say the vertical angle theorem. Now we are ready to say that the triangles are congruent. So triangle ABC is congruent to the other triangle. Okay, so all right, so triangle ABC is like the yellow triangle, and that has to be congruent to the white triangle. But you have to put the letters in the right order. So I see that angle A corresponds with angle E because angle A is empty, it's blank, and so is angle E. So that's why I'm going to put E first. Next comes angle B. Angle B corresponds to angle D. They both have the single mark. Okay, that just leaves angle C. But of course, angle C from the yellow triangle corresponds with angle C from the white triangle. All right, now for the reason. Which of these reasons is it going to be? Well, look at the yellow triangle. Look what we have marked. I see two angles and a side. That means our choices are, it's either going to be angle, angle, side, or it might be angle, side, angle. Those are the only choices. For angle, side, angle, the side has to be between the two angles. And that's exactly what's happening here. Notice how the side that's marked, if you just look at the yellow triangle, the side is right here sandwiched in between the two angles. So that's why this is angle, side, angle. All right, let's do 3 more proofs. All right, let's see what's going on in problem number 18. Start with the given. Angle A is congruent to angle D. All right, I see you, angle A and angle D. That is already written into the proof. So let's move on. Segment BC bisects angle ACD. Well, when you have one of these bisector statements, I recommend highlighting the thing that is being bisected. Angle ACD is this angle right here. Just go from A to C to D. So that is the angle being bisected. And bisect means to cut in half. So that means that this side must be equal to this side. All right. Now, what else can we mark on this picture just because of the way, just because of the way the picture looks? Actually, let me pause on that question for a second. We have both of the given statements written down, but this statement leads to something is congruent to something. And really, that's what we just marked. So they told us that BC bisects angle ACD, but the way we showed that in the picture was to mark angle ACB congruent to angle DCB. And that's why these two are kind of connected. I just put a dotted line in between the two to show you that these are a pair. They go together. The bisecting leads to the two halves being congruent. And then the reason is going to be definition of angle bisector. Sometimes students get confused and they'll put definition of midpoint right here. Well, the way you know is because of this big hint right here. If the previous statement says bisect, it's probably going to be definition of angle bisector. All right, now it's time for what I started to ask you, which was, what else can we mark congruent on this picture? Well, the shared side right here, we can mark that. That's going to be the same for both triangles. That is segment CB. So the way you write that down as a statement is segment CB is congruent to segment CB. All right, and of course that is the reflexive property when you have something congruent to itself. Now it's time to say why these two triangles are congruent. I find it helpful to highlight one of the triangles. So you have a yellow triangle and a white triangle. Okay, so triangle ABC, that's the yellow triangle. Okay, and that's congruent to the white triangle. But for the moment, just focus on the yellow triangle. What do we have marked? Notice that we have two angles and a side. That means that this will either be angle, angle, side, or it will be angle, side, angle. If it's going to be angle, side, angle, the side has to be between the two angles. And that is not what's happening here. Here we have the two angles. So there's like one angle here, there's one angle here. This would be the side between them, but that's not the side that was marked. So since the side is not between the two angles, it must be angle, angle, side. Okay, now sometimes that's the end of the proof. if the thing that we were trying to prove is that this triangle is congruent to that triangle, we'd be done. But they asked us to prove something extra, an extra pair of things that are congruent. And the reason is going to be Cpctc. I'm going to come back to that in a second. Actually, maybe I will go ahead and say it now. Here's what Cpctc stands for. It's an acronym, Cpctc. You need to memorize what this stands for. Corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. We're going to use that because this is an extra pair of corresponding parts that we're trying to say are congruent. So, looking at the picture, segment AB is right here. What does that correspond to? Well, that corresponds to segment BD. All right, these are like mirror images of each other. Okay, so you know what? Another way you could think of it, just without looking at the picture, see how AB is first and DB is the first pair. So segment AB is going to be congruent to segment DB. All right, either way. All right. So look, anytime you have already proven that the triangles are congruent and you're being asked to prove an extra pair of things are congruent, that's when you say Cpctc, because these will be corresponding parts of congruent triangles, so they must be congruent. All right, two more proofs, guys, two more. Let's do a purple proof. Starting with the given, angle ACB, so that's right here, is congruent to angle DBC. DBC is right here. All right, that's already written down. Now we marked it. Okay, this is different. Angle A and angle D are right angles. Okay, that's already written down. How do we mark that? So angle A and angle D. Now, it's not good enough just to say that these are right angles. We need to say that they are congruent, right? Just like we said ACB is congruent to DCB, we need pairs of things that are congruent. So that's why anytime you say that two things are right angles, you will immediately say that they are congruent. So A and D are right angles, you say? Fine. That means angle A is congruent to angle D. All right, that's got to be the next statement you have. And the reason is simply that right angles are congruent. All right, that's how you say that. Right angles are congruent. Okay, so that takes care of the given and what flows from the given. It's time to look at the picture and see if there's anything else we can mark. We can mark the shared side. So we can go ahead and say that segment CB is congruent to segment CB. Now, what's the reason that we use when we have something congruent to itself? All right, hopefully you were shouting out reflexive property. And hopefully you said reflexive, not reflective, which is a common mistake. Now it's time to say that the triangles are congruent. And this time we have to make the congruence statement ourselves. So let's color triangle ABC in yellow, just to help guide our way. Okay, they started with angle A. Angle A corresponds to angle D, so that's what I'm going to put first. Next comes angle B. Be careful. There are two angles here at angle B, and it's tempting to just put angle B corresponding with angle B. But in this case, that would be wrong because that's why I colored one triangle yellow and one triangle white. Okay, look at the yellow angle B. Does it have any marks on it? No. The yellow angle B is blank. Now look at the white triangle. Which angle is blank? Well, that's angle C. So the yellow angle B corresponds with the white angle C. Okay, similarly, the yellow angle C has a single mark. And that's going to correspond to the white angle B. Now for the reason, look at the yellow triangle. What do we have marked? I see that we have two angles and a side. So that means it will either be angle, angle, side, or angle, side, angle. It's going to be one of these two. If it's going to be angle, side, angle, the side has to be between the two angles. And that is not what's happening here. All right, here's one angle, here's the other angle. This is the side that's between the two angles, and that's not what's marked. So because the side is not between the two angles, it must be angle, angle, side. And this is not the end of the proof because they've asked us for something extra. An extra something is congruent to something. So whenever you have to go that step further and prove that corresponding parts, an extra pair of corresponding parts are congruent, you say Cpctc. Corresponding parts of congruent triangles are congruent. What are the corresponding parts? Well, I can get it right off of the congruent statement here. AC, all right, because that's the first thing they have, that's going to correspond with DB. So I know it's going to be DB. Okay, and that's AC and DB. All right, that's it for number 19. All right, this is going to be the last one for this video. So soak it in. Soak it in. Oh, and this one's blank. All right, I guess the baby steps are over. Let's start with a given. Let's get the easy part out of the way first. Angle A is congruent to angle E. Angle A is congruent to angle E. And of course, the reason is given. And let's mark that. So angle A is congruent to angle E. Okay, segment CB is congruent to segment CD. Segment CB is congruent to segment CD. Okay, another given. All right. Okay, CB is congruent to CD. All right, that's it for the given. We need another piece of information though. What can we mark just because of the way the picture looks? Well, these angles right here surrounding point C are vertical angles. Now, whatever you do, do not do this. Don't say angle C is congruent to angle C. All right, because that's are you saying this angle is congruent to itself? No, we're talking about two different angles. So you can't name them with the same name if you're talking about two different angles. So what do? We use the three-letter name. So we will say angle ACB. Angle ACB. CB is congruent to angle ECD. And we mark these because they are vertical angles. So the reason will be vertical angles are congruent. Or you could say vertical angle theorem. Okay, now it's time to prove that the triangles are congruent. All right, so we have triangle ABC is congruent to triangle. First, we have to say why they're going to be congruent. So looking at just one triangle at a time, so let's look at triangle ABC, for example. All right, what do we have marked? We have two angles and a side. So that means it's either going to be angle, angle, side, or angle, side, angle. If it's going to be angle, side, angle, the side has to be between the two angles. And that is not what I see here. All right. For example, here's one angle, and here's the other angle that's marked. This would be the side that's between those two angles, but that's not the side that was marked. So, because the side is not between the angles, it must be angle, angle, side. Now, the congruent statement. Angle A is mentioned first. Notice that angle A corresponds with angle E of the double mark. So I have to put angle E first. Next, I have angle B. Angle B is blank. That's angle D corresponding. So that just leaves angles, the yellow angle C corresponding with the white angle C. That's how you do it.